All right, skill 2. So for skill 2, we are talking about products and quotients. Multiplying and dividing. Take a look at multiplying. Now notice it says if you have the nth root of A and the nth root of B, and they are real numbers. That is super important. Then you can combine them under the same radical. That is only if they have the same index. Yeah? So if they have the same index and they're being multiplied together, then you can put them underneath the same radical. The same thing goes for division. If you are dividing two radicals that have the same index, you can then put them underneath the same radical. Okay? All right, let's jump into it. So take a look at example number 2. Yes, we have the same index. The index is a 4. Okay, so fourth root. Well, I'm going to go ahead and put them underneath the same radical. I can do that because the index is the same. Okay, so we have 125 times 405, and that is a very long radical bar, so I'm going to adjust. There we go. And then I'm going to start breaking things down to look for groups of 4. My index is 4. Well, 125 is 5 times 25, and then the 25 can break down to be 5 and 5. Okay, so those are all prime numbers. I'm going to break down 405 also. So let's see, well, 5 and 81. Okay, and then 81 is 9 and 9, and then 9 is 3 and 3. Excellent. Okay, so pulling out groups of 4. Remember, the index tells you the number of terms that you need. So in this case, 4. Well, I've got 1, 2, 3, 4 5s, so I can pull out one group of 5. And then we've got 1, 2, 3, 4 3s, so we can pull out one group of 4 3s. And that's it. There's nothing left over. So this simplifies down to 15. Now, if there was stuff left over, we would have to put it underneath the fourth root. That's the easiest thing for us to forget, is to write the index. Okay, so take a look at example number 3, and it's asking us to simplify. Well, for A, it's asking us to simplify a cube root. We don't have to multiply or divide, so let's just simplify it, okay? The 135 can break down to be 5 times 27, and the 27 is 9 times 3, and the 9 is 3 and 3. Now, I am using the factor tree. You don't have to. It's just my personal choice. Okay, and then I'm looking for groups of 3 because that's my index. So I have 1, 2, 3. I have one group of 3 3s, so that gets pulled out to the outside. And then we have a 5 that's left over, so that's going to be underneath the radical. For the x's, how many groups of 3 can you take, pardon me, from 5? Just one. And then we're left with the cube root of 5x squared. Don't forget the index of the 3. It's the easiest thing for us to forget, but it's so important. Now take a look at B. Okay, the index is 2. Pardon me. And so since they both have the same index, we can put it underneath the same radical. All right, so we have the square root of 48 times 50 times, now x to the 5th, well, I'll write it out, x to the 5th times x squared times y squared times y to the 4th. Okay, when you multiply the same bases, remember your exponent rules, you can add the exponents. So I'm not going to multiply the 48 and the 50 because that is going to be a very large number. Instead, I'm going to look for perfect squares that I can pull out of those. For example, 48 is 16 times 3, and 50 is 25 times 2, and then we have x to the 7th, y to the 6th. When you multiply by the same base, you add the exponents. Okay, pulling out what we know. The square root of 16 is 4. And then we're left with the 3. The square root of 25 is 5. And we're left with the 2. How many groups of 2 can you pull out of 7? Well, we can get 3. And then how many groups of 2 can you pull out of 6? 3 as well. So then we're left with the square root of 3 times 2, and we have 1x left over. All right, here we go. 4 times 5, that gives us 20. X cubed, y cubed, times the square root of 6x. But remember, we have to look for the absolute value bars. X to the 7th, pardon me, that's an odd exponent. So that value is going to have to be positive. We don't have to worry about that. But y to the 6th, if y was a negative value and I raised it to the 6th power, it would be positive underneath the radical. But when we pull it out, since it has an odd exponent, we have to ensure that it is still positive. So we use the absolute value bars. All right. Take a look at C with me. Well, it's underneath the same radical. So let's see if we can reduce underneath. And we can. So that leaves us with the cube root of, well, the 4 and the 32 can reduce. So we get 1 over 8. But we have x to the 4th and then yz cubed. We can definitely reduce from there. Here we go. The cube root, well, pause, sorry. So now I'm going to rewrite it as the cube root of 1x to the 4th all over the cube root of 8yz cubed. You can split it. Remember what we saw at the beginning of these notes, as long as they have the same index. Okay, so then the cube root of 1 is 1, and I can pull out one group of 3 x's, leaving 1 underneath. It's a cube root. It's an odd index, so we don't have to worry about the absolute value bars. All over, well, the cube root of 8 is 2, and I can pull out 1z, and then we get the cube root of y. But we have to rationalize. Sorry. So I need to get 3 y's in the denominator in order to get rid of the radical. I'm going to multiply the top and the bottom by the cube root of y squared. In doing that, in the numerator, we get x times the cube root of xy squared all over 2z times the cube root of y cubed. Aha, that's what we wanted. We needed 3 y's so that we could get rid of that radical. So we have x times the cube root of xy squared all over 2zy, and that is in simplest form. Whew, there's a lot going on, huh? All right, our very last one is now a 4th root, and it's underneath the same radical. Sorry, but I don't see anything that I can simplify, so I'm going to write it as 2 separate radicals, keeping my index. So we have the 4th root of 5y over the 4th root of 18x squared. Nice. Okay, we have to rationalize. Well, 18 is 9 times 2. Shoot, there's not anything else that we can pull out because there isn't a group of 4. Okay, so I'm going to rewrite it as the 4th root of 5y all over the 4th root of 9 times 2 times x squared. So I can see what I need to add to get groups of 4. Okay, so I'm going to because we have to rationalize, don't forget. I'm going to multiply the top and the bottom by the 4th root of. Well, 9 is 3 and 3, so we need 2 more 3's. So we have to multiply by 9. And then I have 1, 2, which means we need 3 more 2's. So 2 times 2 times 2 is 8. okay, because we needed 1, 2, 3, 4 2's, and then we need 2 more x's. Whew, it's a lot to think about, huh? Index plays a huge part. Okay, so in the numerator, we will have the fourth root of, well, 9 times 8 is 72, and then 72 times 5 is 360, x squared, all over the fourth root of, well, 9 times 9 is 81, times 16 times x to the fourth. And then we can simplify the denominator. So we have the fourth root of 360x squared, and 360 is 5 times 9 times 8, so we can't pull out any groups of 4. All over fourth root of 81 is 3. The fourth root of 16 is 2, and then times x. Now, keep in mind, it's an even index, yeah? Whew, I know, it's a lot to think about. Even index, so we do need the absolute value bars because this was even, and this is odd, the final exponent. Whew, nice job, guys. And that is skill 2.